This is a Pulley's question from the mechanics paper, November 2021. So you have a small stone A of mass 3m, which is here attached to one end of stream. Small stone B mass m is here. Initially A is held at rest on a fixed rock plane. The plane is inclined to the horizontal, they give us the angle. String pass over a pulley P is fixed at the top of the plane. The part of the string from A to P is parallel to a line of greatest slope of the plane, so this one. Stone B hangs freely. Coefficient of friction here is 1/6, and stone A is released from rest and begins to move down the plane. So this whole thing is going to move down, and this particle then is moving up. Stone are modeled as particles. The pulley is modeled as being small and smooth. The string is light and inextensible. And using the model for the motion of the system before B reaches the pulley, write down an equation of motion for A. We are going to get always with pulleys the equations of motion just applying force is mass acceleration. So remember, the particle that is moving is going to move with this way. So this is following this equation. This is the resultant force, mass acceleration. So that for A, if we draw all the forces that we have the weight, which is 3mg. We have the tension of the rope pointing up, the friction, because they say is rough, and normal reaction perpendicular. And I don't have anything else. There is only one force that is not parallel or perpendicular to the slope, which is the weight. So I'm going to find the components. This one here, remember this is always alpha. This is going to be 3mg cos because it's adjacent, and this one is always is 3mg sine alpha. We know alpha because we know tan alpha is 3/4. So we have this super triangle, which is alpha 3, 4, 5. So that way we know sine and cos. So the equation of the force, this particle is moving down. So that means my resultant is down. This force is greater than these two together. So my equation is going to be 3mg sine. Sine is 3/5. So I have 9/5 together with these 3. So 9/5 mg, and just multiplying by the sine. Minus the tension, minus the friction, minus the tension, minus the friction is going to be the mass, which is 3m acceleration. And this is the equation for A. And not necessarily you need to substitute this by anything yet. So this is the equation, and this is it. B, they say, show that the acceleration of A is this one, so 1/10 of g. Acceleration of A, which is the same that acceleration of B. Yeah. The acceleration, I have one equation here with acceleration and with tension. So these are my two unknowns because I am able to find friction very easily. So I need another equation with acceleration and tension if I want to find acceleration. So in the particle questions, think that 99% of the time you are going to write one equation for this particle and one equation for this one. And then you will have two unknowns and you can use simultaneous equations. So this force down is mg and this one is t, and it's going to be the same because in these questions always the pulley is smooth. So the equation for B is going to be t minus mg. So t, because it's moving up, so t is going to be greater than mg, is going to be mass acceleration. So again, the same unknowns. So if I need to find acceleration, what I'm going to do is to solve these simultaneous equations. But I don't like this because at the moment it's nothing. So they say, well, it's moving. So if it's moving, friction is going to be maximum. So this is going to be maximum, and it's going to be mu normal reaction, right? Mu is given. So they tell us that is 1/6. So if I find the normal reaction, I will have the friction. Normal reaction is going to be 3 mg cos, and cos is 4/5. So it's going to be 3 mg times 4/5, which is 12/5 mg. So resolving perpendicular to the slope, R is going to be 3 mg cos alpha, which is 12/5 mg. And that means that when I substitute here, mu was 1/6, and this is 12/5 mg, is going to be 2/5 mg. This is my friction. So it means that I have one equation. And so equation 1, equation 2, equation 1 is going to be 9/5 mg minus T minus friction that we found is 2/5 mg is going to be 3 ma. And my equation 2 is T minus mg is ma. And we need A only, but we could find T if we need, yeah? So it's just solving simultaneous equations. So for example, if I add them, I will get rid out of T. So I have, actually we could put this together. So 9/5 of mg minus 2/5 of mg is 7/5 of mg. Yeah, well, I'm not doing now, it doesn't matter. So T and T are cancelled when I add them. So I have 7/5 mg minus mg, because I am adding them, is 4 ma. Yes, adding them together. I can cancel m, and then my acceleration is going to be 2/5 divided by 4 is 1/10. Yeah, that is what I have to be. So 1/10 of g. That's what we needed to prove. Yeah, but as I say, simultaneous equations, we could find T if they ask. They don't, but we could. And then see, sketch velocity time graph of the motion of B from the instant when A is released from rest to the instant just before B reaches the pulley. B is this one. It starts at rest, and it just accelerates with this acceleration. So it's constant acceleration. The forces are not changing. So my velocity time graph is going to be just a straight line, because it's constant acceleration motion. So this, and it starts from rest, so it's going to start in 0. So constant acceleration. And starting from rest. So this is the gradient of this line is going to be, the acceleration is going to be 1/10 g. And you could mention that if you want. In reality, the string is not light. State how this would affect the working in part B. So if the string is not light, if you remember the modeling assumptions that you learned in year 12, that would mean the tension could be different for A and for B. So this tension here and here would be different. So that's what you can say. So tension could be different and could be different. At A and B. Yeah, something like that. And that's all with this question.